Thank you all for coming, and I hope that you enjoy the Fraunhofer location, which we don't usually see because it's in the center of the city. Yeah. Okay, good. Today's presentation is about 5G. You probably have heard 5G is now the greatest buzzwords of everything in the networking. Now 4G is already something in the past. Even countries at the end of the world have now 4G networks. Also, Germany started having a 4G network at the same time. So now I will talk a bit about the research towards 5G of Fraunhofer Fokus. Okay, good. So first of all, who are we? We are a research institute for applied research. And traditionally, we were developing different types of toolkits, software implementations, and so on. And also, since some years, we started gathering them into a bit of a more Lego type of houses, like 5G Berlin, 5G Playground. Now, you might have noticed we have a new logo. It's called 5G Ready Trial Platform. Due to some events and due to a lot of courage from some of our colleagues, we will go even closer towards a product at this moment, trying to reach the borders of what we are allowed as a research institute to do. What is 5G? Well, I mean, if you replace 5G here with 4G, it's exactly the same thing. We have a system to which we have a set of networks that connect to it and a set of devices. On top of them, we are running a set of applications. Probably the biggest difference between 5G and 4G is that LTE is there to stay forever. At this moment, being so close to spectral efficiency, it is highly probable that LTE will remain as one of the networks. Also, 5G will repair one of the biggest mistakes that was done with LTE, meaning the number of devices which can connect per base station. We were running some years ago to get back bigger capacity per device, bigger capacity per base sector, and this actually affected very much the communication as we managed finally to reach the limit of 60 devices attached per base sector. Now, with this narrowband IoT and other functionality like this, we hope that the billion devices promise will be able to connect to the different base stations. Our role into the full infrastructure is the middleware. It was the middleware with SIP Express router. It was the middleware with the OpenIMS core. It is the middleware at this moment into the 5G environment, connecting the devices to the different applications. We call this a double hand model. We have one hand that looks to the upper level towards the different application domains, and the little hand, which is a bit gray, that looks down and tries to integrate different access networks to be able to offer the colored fingers to the upper levels. Now, a very, very short, concise introduction, what is 5G, and actually decanted of every type of details and every type of noise. This is what 5G is. So 5G is a comprehensive communication system, which has user equipment, infrastructure, fixed mobile backhaul, and wide area networks. And this is everything that looks like what we had before. Then comes the new. All the network components are softwareized. Also, Ericsson, Nokia, and other big companies understood what can be done with software. So sorry guys, they caught you. So at this moment they are looking also to implement everything as software and so on due to various factors. Second part is that now with the increase of compute capacity, we are thinking of starting spreading again the system backwards. If you remember a 2G system, it looked very much like this because of lack of possibilities to respond in due time to different requests. We had an RNC here, we had an SGSN, we had a GGSN, and so on. Now, we are moving backwards because we start having more capacity and we don't know exactly what to do with it, but still it's good that we can compute something in other locations in the network, and with this computing in other locations in the network to obtain a, well, better system. One of the tricks of all this 5G is the integration of the local home enterprise factory networks. All this type of networks that up to now were somehow into the private domain and not covered by the operator ecosystem somehow gets integrated into this full soup. How much it will be integrated, operators will say completely. How much it will be integrated, vendors, some will say completely, some will say none. We would like to sell equipment also into this area. Now, the biggest major advantages of this type of software networks on top of the infrastructure is that we can have dedicated networks. Operators realize that multiple programs can run in parallel on top of the same hardware, to make it very, very short. So we can run 2, 3, 5 dedicated networks with the same components customized for the different use cases. Now, network functions can be placed at the different locations, and this is one of the things. And also, one of the things that was missing, especially towards industrial environments, industrial communication, is that common 5G technology can be used also in other environments. Also, the satellite community took a very big step to integrate their satellite backhaul and their satellite front haul as part of the 5G environment. What does this mean? So from a network functions perspective, we are sitting in an ocean of uncertainty. We don't know what hardware we will find when we go to install our software in Philippines. We don't know if that Pentium can actually take all the 10 subscribers that the people will need. We don't know if we can scale up to 1 million subscribers with the 2 servers that they bought because they were cheaper, or God knows. We don't know if this infrastructure is actually reliable, if we can do a correct load balancing between different devices. It's a very, very big amount of uncertainty. So in order to reach some level of carrier-grade type of functionality, we actually need to account of all of these situations. Now, from the infrastructure perspective, the people that come with data center, clouds, and so on, see it very differently. We have virtual infrastructure managers that manage the different nodes of the infrastructure. We have a set of network controllers, mainly software-defined network controllers at this moment. And we have device and connectivity management at the other end. And with this, we can provision everything, anything, anywhere. Everything is scalable. Everything works nicely and elastic. From the perspective of this network, everything is perfect. From the other perspective, we know what scaling means because we need to replicate state. We need to be sure that we replicated the correct state and that we have all the high availability and so on. But from this perspective, everything is fine. We put a super manager orchestrator on top, and the super manager orchestrator will be able to create everything. Now, these are the enablers for this common infrastructure on top of which we are running the software. They are not to be ignored. Their complexity is rather high. Their maturity is not so big at this moment. There is still a lot of work to do also into this environment. And there is a third integrated perspective, how the two worlds, the software and the infrastructure world, can communicate to each other. Adapting the deployments to the service requirements. I want 5 virtual machines. I don't want 3. I want the 5 virtual machines to work from 9 to 11 and so on, this type of operations. If one of the virtual machines fails, I want to restart it. And these are the type of adaptation to the requirements. There is a second part, externalizing part of the functionality towards the infrastructure, because the infrastructure can do high availability, load balancing, traffic steering, put a firewall somewhere, different layers of firewalls, and so on. Question is if you want one at the infrastructure level or a specific one would be required. And of course, provide status on the service and infrastructure, meaning our boxes are not sitting anymore alone in some servers, and we can monitor them with some kind of keep alives at every 5 minutes. At this moment, our boxes are sitting on this unstable type of infrastructure together with others that are sharing the same infrastructure. So we need to know way much better what the infrastructure is doing at this moment to know how to handle this type of operation. Now, the biggest question that everybody put was, why is 5G better than 4G? And after a lot of thinking, we actually got to the conclusion that the biggest advantage of 5G compared to the 4G is flexibility. And it's the flexibility produced by the software. Yes, the radio will be faster. The radio will have a new type of waveform. It will run in higher frequencies, higher capacities, and so on. But actually, the biggest advantage at this moment is the possibility to have a complete customization of the system, to adapt to the infrastructures at the different locations, to integrate with different access networks, and to integrate with the local network. So practically, with the 5G system, we obtained something that the IT world knew for years, that the things can be a bit smooshy, and they can be a bit elastic, and they can be moved around. Let me give you one particular use case of where 5G works and 4G not necessarily. Not necessarily because ultimately it can also work there. This is our favorite Sister Agnes. Sister Agnes is a nurse that has a little car and goes with this little car to all the patients around the city while the doctor waits in the hospital to receive data, to receive multimedia calls. And through this, we have only one doctor, and we are covering half of the Brandenburg region with one car. This car moves around, and the moment that the car reaches the destination, it stops somewhere outside. It has a set of backhaul connections over the LTE, over the 5G, over a satellite. This is not the most important part, but it also spawns locally and 5G, LTE, U type of access networks to which the dedicated devices that are in the bag will start running with her up the stairs to the patient. And then we have a full mobile network to which we can connect all of these devices. Of course, there are a set of issues to take care of, like how to secure the local access, how to secure the backhaul, how to correctly select the backhaul. We actually need a full connectivity map of the region where the car moves, and this pondered in time and so on. It's not so easy. But this is a typical use case that will run into a 5G system and was not possible to run in a 4G system where actually the network was grouped somewhere into the back. This is how, well, the functional components of the Sister Agnes use case look like. This is a suitcase. It costs more than €500,000, includes inside a lot of medical equipment. We have an LTE-U connectivity from this equipment to the car. Yes, all the wireless LAN will disappear in the region because LTE-U is known that it will take everything that's competing into 5 gigahertz. And then we have a set of software components, customized packet core, device connectivity, aggregation of information from the sensor, processing of the information. We need to compress it. We don't need to send more than it is needed over the backhaul. Multimedia acquisition, a media gateway, again with some kind of re-encoding and so on. Local multimedia delivery if we have more people connected to this. And then, of course, we have the doctor and the hospital connected via some kind of routing management and via some security gateway. Great. This is why it's good to have friends. They call you at the correct time. Good. So, very, very short review. If you don't remember from last year, we are running a thing called the 5G playground. We have a set of toolkits. Our toolkits are Open button, orchestration. It runs on top of OpenStack, on other types of clouds, on top of Docker. This one helps to install all the network functions inside the clouds of the operators. Ultimately, they open the door towards the operators and their new environments to be able to install the components. At this moment, it's rather hard to sell a box to an operator, a new box to an operator, without passing through this stage of cloudification. Second toolkit is named Open5G-MTC. Open5G-MTC is an identity manager, device manager, connectivity manager, addressing the integration of different security zones and different private and public networks. OpenSDN Core, it is a new way of doing routing. We follow the SDN principle. We centralize, we distribute. We have all the flexibility in the world at this moment to change path, modify path, and adapt to whatever type of environment. And the flagship toolkit, the Open5G Core, it is a packet core implementation, which, depressively enough for us, it's actually to the same level of novelty as the new 5G core. At the Mobile World Congress in Barcelona, we were 4 people looking like crazy into the new specifications of 3GPP. What is the 5G core? Looking what are the next features, counting how many nights we will not sleep trying to implement all of this. And it was depressively an evolved packet core with some small modifications which we have done already. So now we are waiting for the large innovation that should come from the big vendors. Now, the 5G playground at Fokus is a set of laboratories. Some of you who were 2 years ago, I think, or last year, we had the demo into Fokus, presenting our toolkits and with the presentation of these things. The idea is to create customized systems for different research and development purposes. Now, this 5G playground can be replicated. And one of our main businesses is to replicate these types of testbeds around the world. We are cloning it to different laboratories for different purposes. And this is the research part. Now, in the last 2 years, we have seen a more and more pressure to go not only to do research, development of new features and so on, but to go towards development. And we are talking about product development and enabling the product development with whatever we as applied research we can enable. And we named this the 5G Ready Trial Platform. This was actually a name chosen by despair. We had no time. We had exactly 10 minutes. So we got to this name. Now, what is this 5G Ready Trial Platform? It takes toolkits and technologies with different potential and business potential. It checks the critical technology elements, the things without which the technology would not survive. This is imported from the ministries of United States and their structure of research. And then it assesses if the specific thing is mature enough to go towards a real deployment. There is an integrated system, trial integrated system, and then it's the commercial system. So we are talking about the last stages between a demo and a prototype. After the day the investor came and said, yes, I buy this, I put all the 75 million on the table, up to the day it starts running within the system. And how to enable this. Now, the 5G Ready Trial Platform has actually 2 instantiations. One is this little box. Unfortunately, this is the SIM card. Can you see it? Yes? So this would be the size. It's something like this size. It's a very small box. It's dedicated for edge computing and enables the connectivity of up to hundreds of devices. Underneath, there is a Lenovo ThinkPad. And this is the LTE base station. And the second one is actually our data center with the blades and with the switches and so on, which enables us to run in parallel multiple infrastructure, to have a multimedia one, to have a massive IoT one, and all the others for all the different purposes. Now, we tested a set of technologies at the beginning, which we consider that are essential for this environment. The packet core, the slicing within the cloud, the massive IoT support, the low delay networking. If we get a radio with 1 millisecond round trip time, or even less than 1 millisecond round trip time, it's a pity to lose another 10 into the cloud. And ultimately, we actually lost everything. Plus dynamic spectrum access and spectrum management. It is not yet working in Germany. We don't have any deregulated spectrum. However, it works, for example, in the Netherlands. They have little chunks of spectrum which was deregulated. And this would be the architecture of our trial platform. We have an edge node, we have a central node, and we have this type of fog node where we deploy multiple applications in parallel. Actually, from the perspective of the system, this fog node is a user equipment that has some functionality towards gating within the devices. Plus backhaul management, plus secure connectivity across the backhaul. And this would be the system that we have at this moment. The 5G ready trial platform comes with a set of management components. Management components being, again, orchestrators, the open button. We are still considering to develop an end-to-end orchestrator or to remain with only one across the infrastructure. Device and connectivity management, enabling the flexible deployment of these components within the environment. As mentioned before, this platform is meant to be deployed outdoors, to become a sort of flagship towards 5G developments. However, the platform also addresses 4 of the biggest questions that we received from different industry partners. One is creating advanced prototypes, taking the coal out of the fire with the hand of Fraunhofer, seeing if the prototype works. If the prototype works, good. The company can re-implement it. If the prototype does not work, again, good. It was not so expensive as to implement it by the different companies. Integrating within the existing platform, creating a larger ecosystem, seeing how it works into an end-to-end system. This usually creates trust. Third point is create trust into the product itself, especially assessing the resilience and the security within the system. And then to provide compelling product demonstrators. And I will skip really fast over the next slides directly to the use cases. And these are the use cases that we have at this moment. Multi-slicing, running them in parallel. Edge networking, putting different sorts of infrastructure with edge central and splits like this. Creating a sort of edge intelligence for connecting elevators, lights, and so on into buildings. Providing full turnkey solutions for factories and other smart office and this type of business. Providing some sort of localized service while we have an unreliable backhaul. Connecting cars and devices into cars, creating home networks like mobile home networks within the cars themselves. Sister Agnes, and connecting potatoes. Putting sensors into the ground using technology like LoRa, and then assessing the quality of the soil and how fast the potatoes grow. Plus, earthquakes, water management, crowd control for safety and security reasons, logistics, and so on for demonstrations and public events that are moving through the city. Extending the operator network to the edge, probably this is the last interesting one. This means that we have to convince Deutsche Telekom to put these little boxes in the back of the base stations that at this moment a large part of the vendors already have. Providing connectivity for factory environments. Providing connectivity with low delay to other devices that sit on the factory floor, like this robot connecting the other robots, or this robot connecting other robots to the base station. Massive IoT, connecting dense environments, high-speed automotive, and critical infrastructures, and developing full infrastructures which are highly flexible with devices that move around. This is it. So Thank you very much. Sorry for hurrying you through the use cases. If you have any other interesting use cases, just let us know. Unfortunately for us, we cannot stay anymore into the nice bubble of research. We need to go a little bit closer to reality. Reality is scary, but reality is great. So thank you.
Thank you, Marius. Thank you. And yeah, I think we had Lorenzo going very fast on a lot of text, but you were really going fast on like 67 slides in half an hour. That's really another kind of record we're breaking here. 1, 2 questions here from the audience. So maybe not real question there, but can you detail a bit how companies can approach you, and I'll give to Tim, but how they can use your infrastructure that you have there?
Okay, so to reach us, this is the email address, this is the page, okay? info@5G playground or open5gcore.net. This is the page that we have on the internet. There are different ways to approach this platform. One is come with an application, put it on top, see how it works into this environment. We will shake the environment with different workloads, different situations, modify the radio, and so on. Second alternative is to bring the component within the infrastructure itself, taking out ours, putting a new one in. Third one is take your software and put our components in, like load balancing, high availability components, and so on, and then offer this as a new product. And of course, the biggest catch is to go towards customers together. We are an advertising machine.
So I was curious to know what your feeling is about SIMs in the 5G world. Are they a fixed thing, or are we going to be able to get rid of them in some cases?
We will get rid of the SIM cards, but maybe we will not get rid of the SIM card itself as we expect. There will be something embedded there which will run between multiple IMSs. The reason for this is that the SIM card has a security association with the network. And this is probably the biggest value of the SIM card, not the locking of the subscriber to an identity or so, but this security association. And this is one thing that we would like to keep. The rest is free. Changing IMSs, if you trust the device itself, if you talk to Gemalto, to Sierra Wireless, and so on, why not?
Okay, thank you, Marius. Thank you for hosting the event again.